To our last rule, which is a quotient rule. Quotient is the answer to a division problem. So we're going to divide them today. So let's remember what happens when we multiply. X to the 8th means x times itself 8 times. X to the 3rd means x times itself 3 times. We have a total of 11. So what did we do to the exponents? We added them. Now let's look at what happens when we're dividing. I have x to the 8th in the numerator, which means x times itself 8 times. And then I have x to the 3rd in the denominator, which means x times itself 3 times. Now, we remember that anything divided by itself is 1, so we can cancel 1, 2, 3 of them. And how many are left? X to the 5. What do you think the shortcut is with these? We subtract them. So let's look at this one. 20, x20 divided by x11. You just subtract 20 minus 11, and it's x to the 9. But what happens here when you subtract? You get a negative 3. So let's draw it out and see what it looks like. You had 2 x's in the numerator, and then you have 5 in the denominator. And then you cancel what you can, 1, 2. What do you have left in the numerator? Isn't it just an imaginary 1? And then you have 3 of these. So these two mean the same thing. When you see a negative exponent, to make it positive, you move it to the denominator. So 1 over x to the 3 in the denominator is the same thing as x to the negative 3. And we don't want to leave negative exponents in our answer. So when we find a negative, we change it and make it positive. So let's see what happens here. Let's look at the y's first. 5 minus 1 gives me y4. Now, another shortcut is, see, if you did 2 minus 10, you'd get negative 8. That means to make it positive, it goes in the denominator. But another shortcut is when you subtract, you keep the answer where the bigger number was, the bigger exponent. Because if there were 10 in the bottom and 2 in the top, when I cancel, those 8 left are going to be in the denominator. This one, I don't want to leave a negative. So I move it to the numerator, and it makes it positive. So wherever the negative is, like right here, to make it positive, you move it. If it's in the numerator and you want to make it positive, move it to the denominator. If it's in the denominator and you want to make it positive, move it to the numerator. So here, when everything in the numerator cancels, you have to put a 1 as a placeholder. Let's look at this one. So negative 4 divided by 2 is negative 2. You always do the numbers first. There's an x, because there's no other x's to combine it with. And look, my y2's cancel. So there's my answer. Now what would happen here? 3 minus 3 is 0. But also, anything divided by itself cancels and is 1. So, new rule here. Anything to the 0 power is 1. So if we look at this one, negative 10 divided by 5 is negative 2. Then the a's we subtract and we get a 3. The C0 becomes 1, so I can just get rid of it. Then there's a C7, which does not have anything else to combine with now. If you'll look at your B's, B5 minus B1 is B4, but since the most of them were in the denominator, your B4 goes in the denominator, and